special case factoring and difference of squares. Again, what's the first thing we should always check for when we're going to factor? Descending order. Make sure it's in that right order. Second thing we always look for, greatest common factor, GCF, across the whole problem. So we're going to look for that first. And then the last thing that we're going to do decides, count the terms, decides what process we're going to use to factor that. So we're going to count terms. If there are 4 terms, what do we do? Grouping. If there are 3 terms, X method. That's what we've been doing the last couple of days. We're going to still be using those 2 some in the special cases today. But then the new one that we're going to talk about today is the difference of squares method, and that's if there are 2 terms. We look for this difference of squares method, and just because there are 2 terms doesn't necessarily mean that it has to be a difference of squares, but it could be, and that's what we're going to be looking for in order to factor some of these things that have 2 terms in them. A lot of them that you'll see today will be differences of squares because they're trying to learn that skill out of that. But I want to show you how to recognize that and when is it not that, but still has 2 terms. So descending order, greatest common factor, then we're going to count terms to go from there. So let's just start with one, and it just says factor. And maybe it's x squared plus 8x plus 16. It's like something we've been doing last couple of days. Is it in the right order? Yes. Is it got a GCF across the whole problem? Everybody? These 2 pieces have something in common, but this one doesn't have anything in common with both of those. These 2, but not all 3. So it doesn't have a GCF across the whole problem. So we move on to the next step, counting terms. What method should we use on this one? The X method, because there's how many terms? 3. So what goes in the top of that X? 16 goes in the top. 1 times 16 goes up top. 8 goes in the bottom. So we need 2 numbers that multiply to be 16 and add to be 8. 4 times 4 is 16. 4 plus 4 is 8. So it's the right ones. Now, we can take those 4 x's and put them in the middle and then group. GCF of the first 2 is x. GCF of the second 2 is 4. And then final factors, x plus 4, and then the stuff in front is also x plus 4. That's what makes this a special trinomial or a special case, is because we end up with the same factor twice. Okay, what that's called is a perfect square trinomial. You could also write the answer as x plus 4 parentheses squared. That means the same thing. If you square something, remember it means it put it down twice. It's the same thing there. So what this is called is a perfect square trinomial. Okay, perfect square trinomial. The reason it's a perfect square trinomial is because when you factor it, you get the same factor twice. That's what makes it a perfect square trinomial. There are some properties of the numbers that are in there. If we look at the end, we know 16 is what kind of number? How can we describe that? It's a square number because it came from 4 squared, right? 9 is also a square number. 4, 64, 36, 25, 100, 81. All of those are square numbers because they're the square of some other number. So 9 squared is 81, 10 squared is 100, that sort of idea. So there are some properties of that, but as far as factoring goes, you're not doing anything different. It's a trinomial. You do the X method and it works out, and you just happen to get the same factor twice, and that's what makes it a perfect square trinomial. So it is a special case, but as far as how you do it, it's not any different what we've done the last 2 days. It's exactly the same process for the trinomials because it's got 3 terms, and we learned that process doing that. Let's look at another one, maybe a little bit tougher because it has a number in the front. 4x squared plus 28x plus 49. Is it in the right order? Yeah, we got x squared, plain x, and then plain number. So that gets it in the right order. Is there GCF across the whole problem? 4 goes into itself, 4 goes into 28. Does 4 go into 49 evenly? No, almost. If it were 48, then yes, there would be, but it's not. It's 49. So no GCF across the whole problem. So when we do our x here, what's the top number? Not 49. Remember, to get the top number, you got to take front times back. 4 times 49. 196. And then what goes on the bottom? The 28. Okay, so we need numbers that multiply to be 196 and add to be 28. And that's where the special cases kind of get a little bit more difficult because the numbers get bigger when they're special like this one. One of the kind of the strategies, I guess, would be the best way to describe it for finding the sides of this is to think, okay, well, if I know that 49 is a square number, maybe I can think about 196 and is it a square number? No. 9 times 9 times what is 196? 9 times 22 is not 196. What I'm saying is think about, okay, well, if 196, what's special about 196? Well, if you think about our square numbers, we start 1 squared is 1, 2 squared is 2, 3 squared is 2 squared is 4, 3 squared is 9. Maybe we make a list of them. So here's our number on the left. 1, and then here's our number squared. 2, 4, 3, 9, 4, 16, 5 is 25, 6, 36, 7 is 49, 8, 64, 9, 81, 10, 100, 11 squared is how much? 121, 12 squared, 144, 13 squared,
169.
169, 14 squared. Mm-hmm. No.
196.
7 goes into 196, but 7 times what?
14.
7 times 14 is not 196. 14 squared, 196. 15 squared. How much is 15 times 15? Use a calculator. You get to use one.
225.
225. 16 squared is 256. You keep going. Okay? Knowing those square numbers can help you when you're doing these special case ones. Knowing those square numbers can help you in math class. Okay? So maybe write that list down somewhere. Have it handy as you're working today. So 196 is 14 times 14. What's 14 plus 14? 28. Okay? Because that's a square number up there, one of the strategies that can help you is to think, okay, what squared gets me that number? And it's 14 in this case, and 14 plus 14 happens to be 28. Okay? If that's a square number in the top of the X, you want to think about that in that way, because that can be helpful and a lot of times can give you the right pieces. So we would then take x squared plus 14x plus 14x plus 49 and then group from there. So, and then GCF of those would be 2x. That'd leave us 2x plus 7. GCF of those two would be 7. Be 2x plus 7. And you have 2x plus 7 for the matching piece, and then stuff in front is 2x plus 7. Another way of writing that would be 2x plus 7 squared. I would take either of those things there. But it comes down to knowing your square numbers, and you know them up to 16, you're probably in pretty good shape. You can keep going, you know, much further if you wanted to. But the idea is when we're looking at these trinomials today, recognize, hey, 4 is a square number and 49 is also a square number. So when I multiply a square number times a square number, guess what I get back? A square number. That works like that. Okay. So knowing the square roots of those numbers can be helpful. If we look at, let's do another one. Let's say we had 25x squared. Let's do that one. Well, back up. Let's not do that one. Let's do this. 25x squared minus 30x plus 9. Okay. When I set up my x for that one, what's 25 times 9? If I got 9 quarters, how much money do I have? $2.25. What do I know about 225 based on that chart we made over there? It's 15 times 15. Can I turn that into negative 30? How? Negative 15 and negative 15. And that allows me to then take the short, easy way of getting there. What's the GCF of the first group? 5x leaves what in parentheses? 5x minus 3. And what do I pull out of the second pair? Negative 3. And what's that leave in the parentheses? $5x minus 3. So they match. Means we did something right. So that's 5x minus 3 and 5x minus 3. Or 5x minus 3 squared. Whichever way you want to write that. But recognizing these square numbers is where that's coming from. And again, you know, we might not recognize 225 as squared. Hopefully you do, because we have made that chart right there. But we recognize that 25 is a square number and that 9 is also a square number. So that's the clue to tell you to think, oh, well, what? Maybe this is a square number too. What squared gets me that? So that's the clue that you can use to help you get there with this stuff. It's not necessarily always going to be nice and small, easy numbers. Sometimes we've got to think a little bit more. The next piece, as far as process goes, trinomial, you're doing the X method, nothing changes as far as that goes. The number might be a little bit more difficult to find, but we can use those clues about the square numbers to help us find those for those special cases. Differences of squares is also a special case, or they consider it, most mathematicians consider it a special case. A difference of squares. What's a difference in math class? What kind of operation are we talking about? That would be a quotient. Division is quotient. Difference is a sum is a what? Adding. A product is multiplication. Quotient is division. Difference would be subtraction. It's the only thing left. So a difference of squares is the subtraction of two squared things. So it's a squared minus b squared. If you can rewrite a problem to where you have something squared minus something else squared, you can take a shortcut on the factoring and factor it as a plus b and a minus b. Okay, so we're going to try to rewrite problems as something squared minus something else squared and be able to shortcut the factoring on that. Okay, let's take an example here. X squared minus 16. And this goes back again to that chart of recognizing the square numbers. Okay, we recognize that 16 is a square number, and this is a difference because it has what sign in the middle? Subtraction. It's got two terms, and so it goes back to that instructions at the beginning. If there are two terms, we're going to try that difference of squares method. Well, the only way it's a difference of squares method is if it's got a minus sign in it. If it doesn't have a minus sign in it, then it can't be a difference of squares. So you've got to recognize difference of squares means subtraction problem out of that, and squares means square numbers. Okay, so 16 is what squared? 4. Okay, so we can rewrite the 16 as 4 squared. What squared gets me x squared? What squared gets me x squared? What times itself will get me x squared? X. 1x. X times x is x squared. Okay? What we've done is we've rewritten the problem as a squared minus a squared. What that allows you to do is take this shortcut and have two parentheses, x plus 4 and x minus 4. And you factored a difference of squares. It'll always factor as having the same thing in the front. So x squared would be x and x. 4 squared would be 4 and 4. One's a plus, one's a minus. Always going to be that shortcut. One's a plus and one's a minus if it's a difference of squares. If we look at another one, let's say we had x squared minus 25. It's two terms, so that's what first triggers me to think of this, is it's got two terms, and it has what sign in the middle?
Minus.
A minus. That tells me, hey, it's possibly could be a difference of squares. Is 25 a square number? Yeah, it's what squared? 5. What squared gets me x squared? X. What are the factors for that? Because I could write it like that. That means it's a difference of squares, so that means the factoring is super easy. Good job. That's it. Gonna if we multiply this back out, x times x is x squared, x times negative 5x is negative 5x, then a positive 5x. Negative 5x and a positive 5x will cancel each other out. And then what's positive 5 times negative 5? Negative 25. So it works, if you multiply this back out, it gets back to the original problem. And that's to check to see if it's right. That's the way you can check it out of that. So being able to recognize that is the key to being able to do these today. So Let's say we had 9x squared minus 1. A little bit more difficult one because it's got a number in the front part. But here's the things that I'm looking at. I'm saying, okay, is it in the right order? Is it in descending order? Yeah, we got x squared, and then we got a plain number. So that's in order. Is there GCF across the whole problem? No, 9 and 1 don't have anything other than 1 in common. The next thing to look at is how many terms are there? 2. What kind of sign in the middle?
Minus.
Minus sign. So that meets the criteria for possibly being a difference of squares. So what I try to do is think, okay, well, is 9 a square number? Yeah, so it's 3 squared. But to get 9x squared, I need 3 what? 3x. Is 1 a square number? Yeah, it's 1 times 1. So I was able to rewrite it as a difference of squares. Okay? Because it's a difference of squares, that allows me to factor it. 3x plus 1, 3x minus 1. Example G. Is it in descending order?
Yes.
All right. GCF across the whole problem? No. How many terms?
2.
Minus sign in the middle?
Yes, sir.
Yeah. So it could possibly be a difference of squares. Okay. Is 8 a square number?
Yes, 4.
No. Is it in that list?
Yeah.
8 is in the squares list. The only square numbers I see are 1, 4, 9, 16, 25. I've already passed it. If it was a square number, it'd be between here and here, right?
Yeah.
It's not. 8's not a square number. 9 is, but 8 is not. So that means this is not a difference of squares. It did not meet the requirements to be a difference of squares. It had the right number of terms. It had the right sign in the middle, but it's not a difference of squares, which means it won't factor. So this would be one of those that's prime. Okay? You got to go through that checklist in your mind for these things to decide if it's a difference of squares or not. If it's not a difference of squares, it's not going to factor that way. Likely won't factor at all. This one won't factor at all. There's no GCF or anything that you can do. So you've got to recognize those things. Let's look at this one. 4x squared minus 49. Is it? What do you mean? Yeah, Logan, take us through the steps there. You're right, but take us through the steps. It's in descending order. Good. Doesn't have a greatest common factor because 4 and 49. 4 doesn't go into 49. We had that one earlier, so we know that that's not the case. So it's got how many terms? 2, and what kind of sign in the middle? Minus sign. So we're going to check it for difference of squares. Yeah, 4 is in the list and 49 is both in the list. So that means, hey, these are square numbers. I can rewrite this as what? 2x and 7. So the factors are then 2x plus 7, 2x minus 7. Yeah. All right. Let's say we had 4x squared minus 36. So a similar problem, different number on the end there. It's in descending order. What did we skip? Which is? What goes into 4 that also goes into 36? 6 can't go into 4, it's too big. 4 goes into itself. Does 4 go into 36? How many times?
9 times.
9 times. So 4 goes into both of those. So the GCF is 4. I'm going to pull that out first. That gets me 4 parentheses x squared minus 9. So I've got the GCF out. Now I'll look at the parentheses and say, can I factor that further using difference of squares? Because we already said it had 2 terms and it was a minus sign in the middle. So can I rewrite x squared minus 9 as a difference of squares? Is 9 a square number?
Yes, 3.
It's 3. What squared gets me x squared? X. So that means it's a difference of squares, and the factors are and then that 4 from the beginning comes down there, and then there's the factored form for that thing. So GCF at the beginning pulls that out. Now, could you factor that as a difference of squares without the GCF? Yeah, but your final answer would have been wrong because you didn't have the GCF out of it. And you would have had to have done GCF at the end, technically twice, because you'd have a GCF in both factors at the end. So that's why you want to do GCF for the whole problem at the beginning. One thing is it makes the number smaller, and it's less work at the end. Okay, let's do a couple more. We'll be done. 9x squared plus 25. Descending order?
Yes.
GCF? Not 1, okay? How many terms?
2.
2. It's adding and not subtracting. So can it be a difference of squares if it's adding? No. So that tells me I cannot factor this with difference of squares method. It won't factor, period. It's prime. And the difference in this one and the other one, the reason this one's prime is, like Ty said, it's adding. It's got to be minusing for it to be a difference of squares. Okay? If it's not got a minus sign in it, then it can't be a difference of squares. Okay? Negative 9x squared plus 25. Almost the same problem. One key difference.
It's negative.
It's got a minus sign in it. Is it in descending order? Yes. Is there a GCF?
No.
Not really, but there kind of could be one to turn it into a difference of squares. What can we pull out of this to put the minus sign in the middle? What will go into 9 that will also go into 25? 9 won't go into 25 evenly. But there is a number that will go into 9 and 25. 3 goes into itself, but it doesn't go into 25 evenly. One does. What kind of 1 can I pull out to get the negative off of the 9? If I pull out a negative 1, that's going to make that positive 9x squared. And what times negative 1 gets me positive 25? That's a minus 25 there. That turns it into a difference of squares by factoring out that negative 1. So this is an exceptional one. It's probably maybe the toughest one we've done all day, because you've got to recognize, hey, the minus sign needs to be in the middle. So if it's in descending order and the minus sign is in the front, the trick is pull out a negative 1, and that'll put the minus sign in the middle. Okay, that's what I want you to see out of this. And then that allows us to say, okay, well, 9x squared is something, and yeah, it's 3x, and 25 is 5. So that gets us the factors 3x plus 5, 3x minus 5, and then don't forget the negative 1 we pulled out at the beginning. It is easy. You just got to recognize the exceptional ones. Okay, so we pulled this -1 out at the beginning. What times 9, or what squared gives me 9x squared is 3x. What squared gives me 25 is 5. 3x plus 5, 3x minus 5. This -1 has got to be there because we had it at the beginning. Okay. The key to being a difference of squares is having a minus sign in the middle. I couldn't factor out a -1 on this example because there wasn't a negative on either of them to pull. If I had pulled out a -1 on this one, it'll change the sign of both of them. And that doesn't work. Square numbers are never, it's not going to work to have them as a negative. Okay. All right. It's going to take some practice.